I'd like to start by looking at a comparison between indefinite integrals and definite integrals. Now, an indefinite integral is like an antiderivative. Now, if we get the indefinite integral, I'm just going to show you how that's written. So the indefinite integral of this function, 2x plus 1, with respect to x, is written this way. So let's take 2x, raise the power by 1. So we raise the power from a 1 up to a 2, so that becomes x squared, and we've got that 2 in front of it. And we have to divide by that new power. So we raise the 1 up to a 2, and we divide by 2. Okay, so this is integration. Let's look at the next one, which is plus 1. The antiderivative of plus 1, we raise the power up by 1. This is x to the index of 0. So we raise the index by 1. So it becomes x to the 1 from a 0 up to a 1, and we divide by 1. Now, there isn't a plus 0 here, but when we derive the antiderivative, we should get 0. So we have some sort of constant. The derivative of a constant is 0. Now just check if you've done it correctly. The derivative of the constant is 0. The derivative of x is 1. And the derivative of x squared is 2x. So if you get the derivative, work backwards, you get the derivative, and this way and this direction is antiderivative, which we call integral. To go from 2x plus 1 to x squared plus x plus c. So our indefinite integral is x squared plus x plus c. Okay, so let's just all right. Let's move across now to definite integral. Now a definite integral, notice we've got numbers here. Over here, we don't have numbers on the integral sign at all. But over here, we've got the number 1 and the number 3. So we're going to have a definite integral between the values for x equals 1 and x equals 3. Now let's see what that requires. So here we still integrate 2x, so that raise the power from a 1 to a 2 and divide by the new index. 1x to the power of 0 is 1x to the power of 1. And we don't need to worry about a plus c. For definite integrals, do not need a plus c. So there's already a difference between indefinite integral and definite integral. We put the 1 and the 3 down here. Okay, let's simplify this. We've got, really, it's saying x squared plus x from 1 to 3. Up here, we have the function. And down here, we have the antiderivative or the integral. Now, what we have to do with the 3 and the 1, we've got a 3 and a 1. So what we have to do is first substitute 3, then substitute 1 and subtract. All right, so let's put a 3 for x. All right, so that is 3 squared plus 3. Okay, now the second bracket, we put the 1, the lower number here, and that's replace x with 1. So that's 1 squared plus 1. This will give us 9, 10, 11, 12, take away 2, and our definite integral equals 10. Okay, so this equals 10. All right, so we've just looked at the difference between indefinite integral, where we have x squared plus x plus c, and definite integral. We still have x squared plus x. We don't have a plus c. But now we've got these numbers, so it's definitely between 1 and 3. So you substitute 3, substitute a 1, and you subtract those two results. Now on the next, I just want to show you this. How is the definite integral related with what we call, we use the definite integral, we use this to find area under the function. And I'm just going to show you the area under a y equals 2x plus 1 function. Okay, so let's go to, I don't know what just happened there. Screen is blue. It's all right, let's continue. So I want to look at from x equals 1 to x equals 3. And I want to show you, oh, there we go, it's gone. I want to show you that the area underneath the function between x is 1 and x is 3 is going to equal 10. So let's have a look at this as a trapezium. This looks like a trapezium. And if you remember the rule or area of a trapezium, this will test you. It's half the two parallel sides, a plus b, times the distance between those parallel sides. So a is 3, half. This parallel side is 7, so b is 7. And the width between them is 2. So we've got an area of 10 square units. Now, notice 10 square units, that's the area. The definite integral is simply 10. We don't say 10 square units. However, we use the definite integral between 1 and 3 is also used to find the area under the function between 1 and 3. And I'm just going to add a small little note here. And it's important to note that our function, our linear function, did not cross the x-axis between 1 and 3. It's important to note that because this is important when we're doing area and definite integral. It's important to keep in mind that we're dealing with the area. The whole function is above the x-axis. It didn't cross over. And we'll look at another lesson where that actually does.